Okay, good morning, everybody. Good morning. Thank you for coming along today. I hope you've enjoyed the keynote. I missed the keynote this morning because I won't say I overslept, but I slept longer than I wanted to. So we'll move on from that. But thank you so much for coming along to the second NDC Copenhagen. Out of interest, how many people here came here last year? Some of you, a few of you were here last year. Okay, that's great. Well, hopefully we'll be back next year as well. So today I'm going to be talking about sort of what cloud native means, what it is, and maybe what it isn't. It's a bit of a murky topic in a way, because I think everyone's talking about cloud native stuff, but there are so many different views about what cloud native means and what it is. And I think in many ways it's just a continuation of our drive to create higher and higher order abstractions, but we'll come back to that. My name's Sam Newman. I run my own company doing sort of training, advisory, and consultancy work. I sort of work mostly across Europe. Do a lot of work actually here in Denmark. If you want to know more about anything that I do, you can go look at my website, which is easy to find. It's samnewman.io. I should really put a link on the slide. I also wrote a book a while ago on building microservices. Has anyone here actually read my book? Okay, for those of you who haven't, you can buy copies. That's fine. Yeah. If you have read the book, you're still free to buy copies. I am actually working on a new book which should be coming out by the autumn of this year, which is going to be on system decomposition. I just need to explain. Some people view people who come up on stage as experts and assume we know everything. That's far from the truth. I started working on a second edition of this book, and I took the chapter that was all about how you break things apart into smaller pieces, and I thought I'll change that chapter first. So a chapter about making things smaller, that's the chapter I'm going to update first. That chapter went from being 5,000 words to being 35,000 words in the space of 6 weeks. So a chapter about making things smaller got really, really big and is now its own book. So just in case you thought I was some kind of expert, that is very far from the truth, but there'll be an early access version of that book available hopefully by the middle of the year, which is fast approaching. So I'm getting a bit worried about that. But we're here to talk really about cloud native, which is something that sort of, I suppose when I wrote that book, 2014 is when I wrote that book, we weren't really talking about cloud native as much. We were talking about things like 12-factor apps, but now everybody's talking about cloud native, certainly vendors anyway. But it's a bit of a confusing topic, this term, cloud native. But here's a couple of things I want you to take away straight away. Firstly, it is all about abstractions, cloud native. It's all about just a new and defining a new set of abstractions that we're happy to deal with that hopefully will give us more power. The second really important thing I want you to take away is it's not all about Kubernetes. So just want to put that out there straight away. Kubernetes will not solve all of your problems. It is not the answer to all questions, unless the question is, right, anyway, let's move on from that, because some people get really religiously zealot-like about using Kubernetes, which I find quite bizarre, but we'll move on from that. We've been working with cloud platforms for a long period of time. I myself was working with AWS from about 2008, and Amazon was the first example of a provider that was giving us what we now consider to be a modern public cloud provider. And core to that offering was the ability for us, through code, to provision things that we would traditionally think of as infrastructure or as systems that would require a whole team of people. Now, we didn't need a team of people to do things. We could use a line of code to spin up a machine or to spin up a message bus or something like that. I started working with Amazon, as I said, about 2008, 2009, which is quite a long time ago now. But AWS actually was first launched in 2006. Which many people don't realize. The first offerings they put out actually had nothing to do with really sort of running a virtual machine. It was actually running the queue, SQS, the simple queue service, was the first product that they released, which is kind of interesting because that's a higher order abstraction product than the ones they then went on to push in terms of things like the big three of infrastructure as a service being storage, networking, and compute. This was sort of a higher order offering that they put out, and it didn't really gain any traction at the time. We also, though, of course, going back even further than that, had already started to talk about cloud with things like Salesforce. So we can tell Salesforce is in the cloud because of the logo. And this was kind of interesting because I was working with clients around 2009 to 2010. I sort of realized the potential of something like an AWS platform because it enabled people to provision infrastructure more quickly, and that helped people ship code more quickly. You didn't have to raise tickets. You could just run a line of code and things were done for you. So I liked that property. And so I was doing whatever I could to encourage people to move over to the cloud, but people were scared. It's like, well, I don't trust these people. I don't trust these people. I don't know what they're up to. You know, what if they shut the thing down? They're a bookseller. Why would I run my computing workload someone that sells books? And why would I run any of my data on somebody else's machines? My data's got to be safe. And then I say, you use Salesforce, don't you? And they go, yeah, of course I use Salesforce. Of course I use Salesforce. It's 2008. Of course you use Salesforce. And of course, Salesforce was on the cloud. In many ways, Salesforce legitimized this idea for many of the larger corporates of having your data and processing running somewhere else. That actually became a convenient thing for me because I could have those conversations with people. You've already done this. Salesforce, by the way, was 1999 that came out. We're in its 20th year, really, since being officially launched. Another great example of an application that drove a very successful company, continues to be a very successful company, no matter what you might think of Salesforce. The market cap was somewhere north of $60 billion, and most of that was built on top of a very old Java monolithic system. So any of these idiots out there telling you that microservices are the way to go, I clearly don't know what they're talking about. You should ignore them and pity them wherever you see them, because monoliths are definitely the way to go, right? Okay, coming back to a bit more of a history, a bit more recent history than that would be probably Heroku. Heroku's now owned, of course, by Salesforce, which hasn't really worked out as well as I think many of us hoped at the time. Heroku, which was for many years the gold standard for how we would run as application developers, as how we would run application workloads. I think it really still is the best example I've seen of a developer-friendly platform for running and managing code. It's kind of really interesting to me that I don't think either AWS or Azure has come up with something that is as friendly from a developer point of view as Heroku did back in 2007. You see many platforms since have basically copied what Heroku did regarding the developer interface. Pivotal completely rebuilt Cloud Foundry to give people effectively a clone of the Heroku developer experience. And there's something interesting about that. I still think that too many of our public cloud providers use what I'd consider to be inside-out thinking, trying to build higher-order abstractions from lower-order primitives without really thinking enough about the end-to-end developer experience. If we think about something like Cloud Functions or AWS Lambda, which is at its heart such a simple, beautiful idea for how we deploy and manage code, and then you go through the train wreck of trying to get a simple Hello World application running, click through 25 screens. It's just insane. Anyway, that's a separate rant for a separate day. We're here really to talk about this. What is a cloud-native application? Now, Heroku, actually early on, people behind Heroku came up with something called the 12 factors, the 12-factor application. Have any of you here heard of the 12-factor application before? Put your hands up if you have. Maybe some of you have. Okay, some of you have. It's actually a really nice set of principles and design principles and design constraints for how we construct applications. And to an extent, this laid down the playbook for how we build applications that work well on the cloud. There's guidelines in here that sort of talked about how you would build an application that would work well on the Heroku platform. So it wasn't like a generic, this is a great idea. It was about, this is how you build applications that work well on Heroku. This also laid down some groundwork for how we think now about building applications that sit happily on the cloud. There's kind of all kinds of interesting things in here. Thinking about backing services, treating things that we talk to effectively as connected services. There's some interesting sort of prior art there, and we start thinking about microservice architectures, but also about thinking about the ability to spin up databases and things on demand, which is something where private cloud providers still really do lag behind the public cloud vendors. We also have things like processes. I'm an old Java programmer. You would have one big fat JVM running loads of applications, and you'd scale up by throwing more and more memory at the big giant box. And here comes Heroku who says, oh no, we should just scale by process. And it's like, what are we, Perl programmers? What is this? 1998, we're doing CGI bin all over again, but yes, kind of we are. Now, the 12 factors remains actually a fairly good overview of how to think about designing an application that's going to work happily on the cloud. It's not necessarily tied to any particular platform, but if you follow these guidelines, to a large extent, you're probably doing okay. And this is often the issue, that we take our existing applications and look at them and think, well, I want to move them to the cloud, and it follows none of these guidelines whatsoever. And so you do that classic lift and shift, wouldn't you? You'd pick your application up and you'd move it over to the cloud, and you sort of stuff it in, and it wouldn't quite fit. So you'd put your foot on it, and you'd hit it with a hammer, and it would sort of work on the cloud a bit, but it would fall over in weird ways every now and then. But we make do, because sometimes being unhappy on the cloud is still better than being unhappy than unhappy on your own machines. But 12 factors. 12 factors isn't, in my opinion, cloud native. It's more like cloud friendly. So let's talk about cloud native. So I went looking for good definitions of what cloud native is. Very quickly, I came across an organization called the Open Data Center Alliance. And the Open Data Center Alliance have a maturity model. I always like a maturity model because it's very, very easy to poke fun at maturity models. I don't like them in general because they kind of imply that being more mature is better than being less mature. And as somebody that hasn't quite grown up, I don't think that's true. It also kind of assumes that you always want to strive to be at the top level, which is rarely the case for most maturity models. And also, I still remember the CMMI stuff from the Software Engineering Institute, and so I come out in a rash whenever anyone talks to me about these things. But let's take a look at the Open Data Center Alliance maturity model for what a cloud-native application should be. There's always different interesting levels. There's some stuff in here that's kind of interesting. But let's go for the top level, because that's what we're all aiming for, right? And they say this: applications can dynamically migrate across infrastructure provider without interruptions of service. So straight away, we need to deal with one of the big lies around cloud computing, that the platforms we deal with are somehow utility, that we can port seamlessly from one provider to another. That was sort of the promise that we spoke about back in 2010 when you started seeing more competition in the space. It's rubbish. You can't do this. No one does this. No one takes an application and dynamically shifts it from one platform to another to eke out some cost effectiveness. You might design an application to run across more than one provider. You might, as an organization, have applications that will target different cloud platforms. But the idea that we're going to transparently move our applications around without anybody ever noticing is fantasy, because the platforms have a lot more stickiness than we realize. I mean, stickiness in terms of how we set up rights management and ownership and roles and billing models and all of these sorts of things. This idea that we can quickly switch between providers is not really true, and I'm not sure it ever is going to be as true as we'd like it to be. Also, by this definition, companies like Google and Netflix would not be cloud native, because they don't dynamically migrate across providers. Netflix just says, we're an Amazon shop. And you know what? We're going to get really, 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 really good at using AWS. In fact, we're going to be so good at using AWS and give them so much money that AWS will do what we want, which is kind of a weird thing to consider. But that's the thing. Amazon released their instances providing SSDs much faster because Netflix wanted them to. And when Netflix give you that much money, Netflix investors are mostly basically propping up Amazon's bottom line at the moment, and Netflix are kind of a pass-through company for this. Anyway, okay, well, we'll move on, because I haven't really answered the question, what is a cloud-native application? We said that 12 factors doesn't really sum it up, and the open data center thing doesn't really help us too much. So then we probably need to go and look at what the Cloud Native Computing Foundation talks about, the CNCF. So the CNCF are actually part of the Linux Foundation, and the Linux Foundation do loads and loads of great work. I know I'm at a Microsoft-friendly conference. That's okay, because Microsoft are now friendly with Linux. But they, lots of things like Let's Encrypt and stuff came out from the Linux Foundation. And the CNCF are trying to basically curate a whole set of projects together that make it easy for us to build applications that target the cloud. And they've got this charter that they've put up with and that talks about what is a cloud-native application. And so they have their definition of cloud-native. And these are the people who call themselves the Cloud Native Computing Foundation, so they must be right. Or at least they've got the right T-shirts. So here we go. They say a cloud-native application must be container-packaged, dynamically managed, and micro-service-oriented. So micro-service-oriented. So let's take a look at container-packaged first. Why would that be of any interest? Well, containers are useful, actually. I like containers as a unit of deployment, the idea that I have a generic mechanism for managing and deploying containers, no matter what's inside, is a nice idea. They sort of reversed engineered the concept of containers really and said it's like shipping containers, but the term container was used well before we thought about shipping containers. But anyway, if you think about a shipping container, you don't care what's inside it. You don't care if there's grain inside there or a car or some hi-fi equipment, or people trying to flee the UK because of Brexit. It's all the same, right? You have the same connection points. You can have the same tooling to pick up those containers and manage those containers, and you don't care about what's inside. Now, from a platform point of view, that immediately becomes attractive because you allow people to create workloads in whatever language they see fit, but you at the platform level, you get to treat it in a uniform manner. So that's a nice idea, right? So that uniformity is good. We also, of course, get isolated execution. A problem inside one container should hopefully only affect one container. It's a more cost-effective mechanism than virtual machines. The universal deployment mechanism, and also that these things are portable. That was really what was lacking containers have been around for a long time. They predate Docker by quite a long time, by about 15 years at least. Solaris, as always, had these things before anybody else. When you start digging into all this cool stuff that happened, it's like Sun was there first, and you just think, why couldn't you work out how to make money out of all of this stuff? Solaris zones and BSD jails predated containers by what we now call containers by a long way. What Docker did was take those ideas of sort of shared kernel-based containers and put a tool chain and put an image format around that. Before Docker containers, we didn't really have a portable image format for containers, and that's been a huge shift. This is why people like containers. Cost-effective, isolated execution, universal deployment mechanisms, portability, so portability across machine, maybe across platform. When we think about function as a service, so how many people here are using Lambda or Azure Cloud Functions or something like that? Right. A couple of you. Those of you who aren't should try it at least. It's a really, I think it's one of the most I think it's one of the best developer-friendly programming abstractions we've come up with in quite a long time. But we know that under the hood, behind these systems, are containers. You might not be working directly with containers, but it's containers under the hood. With the early versions of AWS Lambda, for example, you could bust out of your function and just see the Docker ecosystem running underneath. Amazon have now actually open-sourced their container runtime that they use underneath Lambda. So really here, when you're using function as a service, containers are under the hood. It's containers as an implementation detail. That's certainly how Microsoft do this as well. So, okay, containers, they're kind of useful, maybe. Dynamically managed, well, yeah, we like dynamic management of these things. Dynamic management here means things like, okay, desired state management, typically is what we're talking about here. So an application, so if you have an application scaled out over multiple nodes, if one of those nodes dies, our application handles the fact that new nodes might be spun up through, say, auto-scaling. So you can use auto-scaling groups on Azure or AWS to kind of maintain a desired state or even increase the number of instances you might have running of something when load increases. And obviously the container platforms like Kubernetes and Docker Swarm will do similar things for you. Desired state management is one of those things that just lets you sleep at night, right? As load increases, your machines spin up. You don't have to worry about things. This is a lovely property. And again, the only reason this is possible is partly because of all the way back to some of those ideas from the 12 factors. If you scale your application by process, rather than just by having a bigger machine, it makes dynamic management possible. Without that, you don't really get the same kind of dynamic management we now expect. And then, of course, we have to look at dynamic-service-oriented, which is clearly completely incorrect, as those of people who have read my book will know, because there is no hyphen in the word microservices. So immediately we can dismiss the entire CNCF charter as being a tissue of lies and fabrication. Actually, I did one of these talks about 6 months ago, and somebody took it upon themselves to send a pull request to the CNCF to get them to remove the hyphen from the charter, and I'm glad to say that PR, I think, was closed very recently. So a victory for me and my book, fighting a one-man crusade against the hyphen brigade. Speaking of hyphens, we have a hyphen here in Cloud Native. This is actually Pivotal's definition. And Pivotal, who have put a lot of store in Cloud Native, they've got some really great, smart people working there. We've got people like Kenny and Josh Long who wrote cloud-native Java applications, work at Pivotal, and they create lots of software in this space. Some of you may have made use of Cloud Foundry, the open source Cloud Foundry, or the various different versions of Cloud Foundry, like the IBM provide or Pivotal themselves provide. This is a platform for building and managing cloud-native applications. They talk about the 4 pillars of cloud-native being DevOps, continuous delivery, microservices, and containers. I suspect what the marketing team were trying to do here was get as many buzzwords as possible on one slide, and I think they may have succeeded. But anyway, so then, it's not just the CNCF that think that microservices are part of cloud native. I'm still not totally sure myself. I'm not entirely sure why you have to have a microservice architecture for your application to be cloud native. I think they're orthogonal concerns to my mind. But what am I? I'm just the microservices expert, right? What would I know? So taking a look at microservice-oriented, why might microservices make sense on a cloud platform? What kind of benefit might that bring? Well, firstly, you open up the possibility of independent scaling. You can scale up those parts of your feature set that require extra load and scale down those parts which don't require load. So this is actually about more cost-effective scaling of process. There is some value in that. I would still say if you've got a monolithic application and scaling is your primary concern, just try having more machines. Just copy out your monolith. That may well give you more than enough headroom before you have to worry about decomposing your application into a microservice architecture. There's something else that gets more interesting is this idea of the right tool and the right job. Because you can actually isolate your concerns within those microservice boundaries, it becomes a lot easier to start to identify, well, what kinds of pieces of functionality could I offload more onto the cloud platform? With a monolithic application, it's very hard to consider how you'd use something like function as a service. But if you've broken your application down into smaller pieces, you might realize, well, hang on, this workload here is currently deployed as a managed virtual machine. This actually could just be a single function running on Azure Cloud Functions, for example. And I could replace all of my need for all the operational management of that particular piece of workload by making it a function. It's very hard to do that, though, if you're still seeing your application as one big giant state. James Lewis says that microservices are an architecture which buys you options. Buys is the important word here. Microservices have a heady cost to them. But once you've paid that cost, you then get to take advantage of lots of different options about how you do things. All of the public cloud providers have a huge variety of options. You now get to fit the services and the workloads to those services that are provided by the underlying cloud providers. And, this is the golden rule of microservices, this idea of independent deployability. This is the main thing I focus on when I do classes or consulting with people around microservice architectures. This is the most important thing with microservice architectures. It's ensuring you can make a change to a service and deploy that service without affecting anything else. If you adopted those ideas, many of the things that we've talked about with cloud platforms like dynamic scaling become much, much easier. Let's look elsewhere for a definition of cloud computing or cloud native applications, because I'm not quite sure Pivotal have got it right either. So we can look at the 5 characteristics of cloud computing that come from NIST in the US. And I actually use this to talking with my clients that say they have a private cloud. And we talk through what their private cloud offering looks like, and we realize it's not really a cloud, is it? It's just another excuse to give lots of money to big vendors. When we talk about what NIST consider to be proper cloud computing, the first thing is on-demand self-service. So I would say still a large amount of the private clouds that my clients use still require people to raise tickets to get machines. So that's not self-service, so they fall at the first hurdle. I have met one client who actually makes use of AWS, but none of the developers know they're using AWS because they're still made to raise Jira tickets to spin up machines. And the operations team then go and click buttons in the AWS console. When I learned about this, it was all I could do not to pull out all of my hair and leave the site immediately. But nonetheless, a lot of private clouds, they fall straight away with this. On-demand self-access, broad network access, which always confuses me slightly. But connectivity in a multitude of means, again, this tends to not be something that probably people get from private clouds. Resource pooling, so you can share resources across multiple different business units, getting cost effectiveness. Again, quite often people will lock down machines to certain billing units within their organization, denying them actually some of the efficiencies. Cost controls in these organizations does muddy the waters of your systems architecture quite a bit. Rapid elasticity. Well, you're often constrained by the number of machines you've got. If you're not resource pooling across these things, that makes rapid elasticity quite difficult. Again, most people running private clouds that I meet don't operate in environments where they even want rapid elasticity. What they're really looking for is a better solution than just using VMware and some kind of measured service. Right? This is what we're looking for from a cloud platform. Okay, so this looks all right. Some of you may have read the State of DevOps report put out by Jez Humble, Nicole Skorsgen, and Gene Kim, and they've now all joined Google Cloud. And they found that organizations that make use of a real proper cloud computing platform are something like 25 times more likely to be high-performing teams. So high-performing teams massively disproportionately use cloud-oriented platforms. And I mean cloud platforms that have these characteristics, not whatever your company decides to call its OpenShift install that you have to use via tickets or whatever. Okay, we haven't really moved it on. What the hell is a cloud-native application? Well, let's try again. Right. So we've got lift and shift, right? We've got picking up an application and dropping it from a great height onto a cloud platform and saying, look, we've done our cloud migration. One of my clients did this by literally exporting VMware images and re-importing them onto the cloud, and they would still maintain and manage that infrastructure by logging into the Windows things through like Citrix and clicking buttons to manage and configure those machines. So lift and shift is characterized by being on the cloud, but really not being very happy with it at all. Your processes don't work, your procedures don't work, the application isn't entirely happy, and you're working against the cloud, not with it. I used to fight against this a lot, but with some of my clients, it still makes sense to do this. Partly because it allows you to get rid of your own internal infrastructure that might be increasing your costs, but also because once you're on the cloud, it can be a bit easier to start getting to grips with what it offers and start adapting your application in place. Certainly from monolith to microservice migrations, having your monolith on the cloud first, I think can be a great enabler for that. Then we've kind of got applications which are cloud ready, and here you're working with the cloud, not against it. You're happy to be on the cloud, but you don't have to be on the cloud for your application to work. Cloud native applications are basically embracing the cloud and only the cloud. They are built to take advantage of a cloud platform. They need to be on a cloud platform to work. And that means you have to buy into a particular cloud platform. So if you think about the 12-factor apps, that's what I consider to be cloud-ready, cloud-friendly. Working with, not against, but you're not really fully embracing any one platform. Cloud-native, of course, is where you're typically buying into somebody else's abstractions that might, in turn, limit your portability, potentially. We start thinking about the serverless offerings provided by public cloud vendors. So think here of things like SQS back in 2006. Who'd have thought it? The first public cloud offering was actually a serverless offering in the form of SQS. We've now got function as a service. We've got the database backends. When you want those, you're having to buy into a vendor's view of what those serverless offerings are right now, even if that vendor happens to be an open source product from Google. So this is where we are, cloud native. We're embracing the cloud and only the cloud. The question, of course, is which cloud? So an application is built to take full advantage of the underlying cloud platform. It's probably, therefore, designed with a specific platform in mind, and it's highly likely not going to work without that platform. It's not going to be happy without it. You're buying into a new type of abstraction, a cloud abstraction. We typically talk about applications which are built to somehow scale that might have some inherent fault tolerances. Part of this comes from the fact that once you buy into a cloud platform and get to grips with the SLAs, you start to realize things. One of the things you realize, for example, is that neither Amazon nor Microsoft with Azure nor Google give you an SLA for a managed virtual machine. There is not and has never been an SLA for a managed virtual machine. There's not even an SLA for any of those providers of virtual machines inside an availability zone. So there's no guarantee that you can spin up a virtual machine in an availability zone. There never has been. You actually have to build your applications to scale across all those availability zones to get any SLA around something as simple as managed virtual machines. That's not new. Many people are still surprised by this. When the availability zone goes down, the application goes offline, and they're like, oh, what happened? So you have to build your applications to take account of that stuff. So you're having to think about these aspects from the beginning. How do I have my application working across effectively virtual data centers? It might be decomposed into services, although I still think this is optional for a cloud-native application. But you're pushing work wherever possible into the platform itself and embracing a high degree of automation. This is where some of the scale aspects come from. When we talk about platforms, we can talk really here about abstractions again. We can think about the cloud, different platforms we've been dealing with, the different levels of abstractions within the cloud computing universe. We started, of course, talking about infrastructure as a service. And then over time, we created higher order abstractions. We're now talking about container orchestration as a service in the form of things like Kubernetes, EKS, ECS, platforms that allow us to manage container workloads at scale. We're not worrying about the configuration of the underlying virtual machines. We're just giving a container to a platform. And of course, above that, we have what I still think is the holy grail for many of us, and that's platform as a service. Heroku solved this in 2007. It was just a bit expensive, right? And it still surprises me that we still haven't got back to that yet. When I start looking at things like serverless, what I'm seeing with serverless are the building blocks for what makes platform as a service work. I think early on, with our attempts to create a platform as a service abstraction, we created all-encompassing platforms that try to do everything for us. The problem with that, of course, is that that creates a bit of a leaky abstraction. With serverless, it's like a bunch of highly abstracted building blocks that we can connect together to create the platform as a service that makes sense for us. And of course, we've got Kubernetes sort of floating around in the middle. This drive for higher and higher order abstractions is something that is not new to developers. Brian Marek, who was one of the signatories on the Agile Manifesto, once said to me, developers turn caffeine into abstractions. That's what we do, right? We take caffeine and we create abstractions, and developers love abstractions. And you think about it, we used to work with machine code. And then people said, that seems like we're not getting as much done as we'd like. So we created new abstractions. We created assembly code. And all the new programmers are using assembly, and all the machine code people are going, look at that, look at this newfangled stuff. You want to be really close to the underlying chipsets. This assembly is never going to catch on. And then at some point later on, we had application code, right? And we started programming in higher order languages, distancing ourselves further and further away from the underlying detail of our chips and our chipsets. And that's natural because we want to get more stuff done, right? Software plays a much bigger part in the world than it ever did 10 years ago, 20 years ago, or 30 years ago. And the impact that software has on the world is out of all proportion with the number of developers going into this. It's not about a number of people programming. It's about programs that can do more, and the programs that we write now can do more because we are standing on top of abstractions created by other people. Now, of course, some people don't like abstractions. Joel Spolsky many years ago said, abstractions are leaky. All abstractions are leaky, which is not quite true. Some abstractions are not leaky. But the truth is, though, that all abstractions tend to hide things from us. And the question when you pick an abstraction is, does it hide too much? If you need low-level control over your memory management, picking a language that does garbage collection for you might be an abstraction too far. The other problem with abstractions, though, is you're buying into an abstraction that might not let you move away from it. People start worrying about being locked in. I'm stuck. I can't get out. That's the problem. I've bought into an abstraction. It's like, I'm only a Windows developer. I can't deploy onto Linux, you poor people. Linux is so much better. But that's the thing. We've been living with this for years. We're stuck somewhere. But the thing is, sometimes you can be stuck somewhere nice. You can be stuck into a place where maybe actually people are going to do things better than you could do yourself. The operating system vendors make better operating systems than you could make, so you use their operating systems. And the cloud platforms are the same. Right? When we start worrying about things like security, there's so much infrastructure that has to be looked at and managed and patched and maintained. Are you confident that your own people can do that for you, or do you want to give that job to somebody who can handle it? Think about a modern deployment topology that we might have. We've got our underlying machine. On top of our machine, we deploy our operating system. On top of the operating system, we have the hypervisor, which vises hyperly, maintains isolation between VMs. It maps physical to virtual resources. This is your VMware, your KVM. This is how managed virtual machines work. On top of that, of course, we then have your operating system, which is inside that virtual machine. We don't stop there, because, of course, nowadays, we're all about containers, aren't we? Containers, Kubernetes is king. So on top of that, we've probably got a container runtime. It might be Rocket, Docker, something else. On top of that, you've then got the container operating system. Yes, that's right. You have an operating system running inside that container. On top of the container, you've now got your application. That's a modern deployment topology. Guess what? Every single one of those layers needs to be looked at, managed, monitored, and patched. We're now even patching our chips, aren't we? We're having to patch our Intel chipsets, our AMD chipsets, when new exploits are found. Some of you might have followed the Spectre and Heartbleed leaks when they came out, would have seen that all the cloud providers actually patched their chips in under a week. In less than a week since those patches were released, every single one of their machines was running those new patches. And how could we tell? Because all our machines went 30% slower, which is very annoying, but at least it got done, right? And that's a nice thing, if you let somebody else handle this for you, you're paying money to people who are experts and hopefully better at you at managing these things, who are offloading these concerns. Sometimes when you're stuck somewhere, you might be stuck in a really nice place that you're quite happy to be in, right? People are always worried about the walled garden. Some walled gardens are lovely places to be. An operating system is a walled garden. It's a walled garden we're very happy with. It's going back to the Cloud Native Computing Foundation and what they're trying to do. And I'm reminded, actually, of something that Werner Vogel said many years ago. So Werner Vogel has been a CTO at Amazon for many years, and he talked about why, in his opinion, Amazon had been so successful with AWS. And they said that what they really focused on was, rather than giving people an all-encompassing platform where you had to buy into everything, instead what they were trying to do was give you building blocks, primitives. They give you low-level building blocks that they themselves would then construct into higher-order building blocks. So you think about something like EC2, which is the managed virtual machine instance. You've got Amazon S3 or the EBS for just disk storage. And then you can construct a slightly higher order primitive RDS, which is their relational database service. Now, if you want to, you can spin up your own EC2 instances. You can connect your own disk and run the database yourself, if you want to, on Amazon or on Azure. Or you could just pay a little bit more and have a fully managed relational database service for you that just uses those same building blocks under the hood. And this is this idea of primitives and connecting primitives together. It actually makes it easier for us to adopt these things. Because, yeah, I might be locked into Amazon or locked into Azure, but I'm not locked into an abstraction that they provide. I can still mix and match what makes sense to me in that platform. With the Cloud Native Computing Foundation, we're seeing similar things. So the CNCF is trying to make it easy to curate a set of projects together that allow us to more easily build cloud-native applications, but they're doing so with a view to things that could be portable across vendor. They're not trying to come up with a solution for how you do tracing. They're trying to curate multiple solutions for distributed tracing that are compatible with each other, which I think is a nice idea. I think people hear CNCF and they think Kubernetes. Kubernetes is not a platform, by the way. Kubernetes is just, again, it's another primitive from which you can build a platform. It's a primitive that provides you container orchestration. By itself, that's not much of a platform. The reason that IBM bought Red Hat was entirely down to OpenShift. So IBM's own cloud strategy wasn't going terribly well. They weren't getting much traction. Red Hat has been selling OpenShift like hotcakes. OpenShift is Red Hat's platform built around Kubernetes. And it's proving really popular. That's why IBM spent all that money on Red Hat. But by itself, open source Kubernetes, it's just a building block. You have to build things around it. So the CNCF is trying to curate a set of things around it to make it work. And their hope is that it's at least going to be platform agnostic, right? So it should work with a variety of architectures and operating systems. They're really asking us, though, to buy into a new set of abstractions. They're asking us to buy into a set of abstractions that are now based on Kubernetes rather than the provider. I'm still not sure that's the right thing to do. But anyway, it's better than what we had in the past. A lot of people now are using Kubernetes to provide on-premise private cloud. And I actually think that what's unfortunately happened, and I think it's completely accidental, is that the rise of Kubernetes has allowed many organizations to indulge this fetish they have for running their own machines, right? When OpenStack came out, it's like, oh, we can have our own Amazon. Then we realized we can't. And just as though all of that, people were realizing that, oh, Kubernetes, it's going to solve those problems again. We keep indulging this sunk cost fallacy. Why do we run stuff on machines that we run and manage ourselves? Because we've got machines. Okay, well, we'll run on them. Okay, but why are you buying more machines? Well, because we run stuff on machines that need to be updated. We continue to invest this time, energy, and money and provide to our developers platforms internally that don't stack up to what we can get from public cloud providers on the whole. Because managing Kubernetes is not a trivial activity. That operational cost doesn't vanish. It's still there. It's your people now have got to learn all of these skills, and you've got to hope they can do that better than the experts. We also, when we're dealing with on-premise deployments of these cloud platforms, we tend to be dealing with much lower level primitives. What's our equivalent of cloud functions? Oh, that's okay, Sam. There's 15 different frameworks for running functions as a service on top of Kubernetes right now. Sorry, make that 16. Sorry, make that 17, right? None of them are as good as any of the cloud fast platforms that are out there. Is there something as simple out there as RDS, a service where you just click a button and you get a managed database service? Can I get that on-premise? No. That's really hard. Turns out, something that looked really easy, under the hood, is really, really hard. It all comes down to this, weirdly. This is still the big, big problem. You might say you've got a private cloud and it's all magic and we've got all this lovely open source software. When it comes to data and storage, you're still giving a 7 or an 8 figures check to NetApp for a big SAN to run loads of disks on your behalf. That stuff is still really hard. You might be able to provision a container and spin that up on demand, but what about disks? What about data? What about storage? And we all work with these things. And this is, I still think, the thing that stops our on-premise computing environments from being any good. The Cloud Native Computing Foundation are doing a lot of things about creating standards to enable interoperability, and they're doing this mostly, I think, in the right way. Unlike sort of previous attempts to standardize things, they're looking at open source tools that work well, that get adoption, and trying to extract from that sort of protocols and specifications that should help other people interoperate with each other. So a good example of that would be something like the Open Tracing API. This was originally pioneered in the open source world by Zipkin. Zipkin, in turn, was originally inspired by the work at Google in Dapper, a system for doing distributed tracing. There is a need with a cloud-based system, well, actually certainly with a microservice-based system, for tracing and distributed tracing. So by encouraging the open sourcing of an open specification, you allow both commercial and open source vendors to create solutions that now can interoperate with each other, and that's been quite successful. And there are loads of members now behind driving this now. Amazon spent a long time. They were the last people to join, pretty much, of the big people. Because Amazon didn't embrace Kubernetes. They had their own ECS service for a long time. But then they suddenly realized, hang on, all these people running Kubernetes are running it on Amazon anyway, so we might as well join in. They're not stupid. So we're now, we're getting people working together, kind of. It's better, maybe, than what we were doing 20 years ago, certainly 10 years ago. I still come back to this idea of abstractions. We started with chipsets. Now, we used to target specific chipsets, and then we started targeting specific operating systems. I'm a Windows developer. I'm a Linux developer. Now what's happening is we're targeting certain cloud providers, or we're targeting certain container platforms. It's no different. This gets deployed on Red Hat, this gets deployed on Ubuntu, this gets deployed on Windows Server 2016, this gets deployed on AWS, this gets deployed on Azure, this gets deployed on a Kubernetes platform. Kubernetes as a portable, theoretically portable platform, the idea is nice. The idea is I can spin up a whole platform stack on AWS and target that stack. I could spin up that same platform on Azure and target that. But you still sort of have the lowest common denominator platform. If you just target Kubernetes and that Kubernetes ecosystem, you're denying yourself the opportunity to take advantage of the really cool, more highly abstracted services that those cloud platforms provide. I mean, things like the fast platforms. You don't really get anything else like Azure durable functions on any other platform, or AWS step functions, which are not nowhere near as good as durable functions, right? When you target just this, what you gain with targeting Kubernetes as your deployment platform, where you theoretically have portability across provider, even though no one actually does that, you're still denying yourself the opportunity to take advantage of the really cool stuff that these cloud providers are doing, when they are now attempting more so than in the past to differentiate themselves. I think Microsoft is doing a much better job, for example, around cloud functions than AWS is. We come back to this pivotal containers, microservices, continuous delivery, DevOps. And I think really we have sort of seen a culmination of a whole lot of things coming together. I'm lucky enough to have started my development career just before Agile. I'm a little bit older than I look. I remember playing around with DSDM and Crystal and all these sorts of things before we called them Agile. And the DevOps movement very much came out of some of the ideas behind Agile. The idea of breaking down barriers, shipping software more quickly led to a lot of the work around the DevOps movement. The continuous delivery movement came out directly out of trying to implement the concepts of Agile within the enterprise organizations. And there was a lot of crossover between DevOps and the continuous delivery movement. Out of that, cloud became even more powerful. The reason AWS was created was because it served a need that Amazon themselves had. They wanted their teams to self-manage their infrastructure, to be able to deploy things quickly. And to do that, they provided services that their own developers could automate to spin up machines. The driver for faster delivery that came straight out of the concepts behind Agile led to the creation of what we now see as the public cloud and helped us build on these ideas. Microservices, Neil Ford says that microservices are the first post-DevOps architecture. The ideas behind microservices are definitely not new. Any of you who came to my workshop the last couple of days will have heard me talking about stuff from the 1960s and the 1970s, right? These ideas have been around for a long time, but the technology and the techniques we have now make these kind of service-based architectures more applicable than they were in the past. So cloud native is really trying to pull all of these ideas together. It's the logical conclusion of all of this stuff. It's a whole bunch of new ideas coming around. I think the sticking point is we've now got to get happier with a new set of abstractions. And for some people, that's an unhappy journey to go on, and that's okay, that's normal. I'm much less firm on this stuff than someone like Simon Wardley is when it comes to talking about serverless. For me, serverless-based computing is probably the future. Most developers do not care at all about Kubernetes and shouldn't care about Kubernetes. I look at Kubernetes and still think, it's still nowhere near as good as Heroku was back in 2007. That's what we want. Developers actually want higher order abstractions. They just want to run their code. They don't want to worry about detail. Kubernetes is detail. In 5 years from now, no one will be worrying about it. It will be there, but it will be underneath something else you're using. It will be underneath another set of abstractions that we're working with, and we're starting to see the emergence of those abstractions kind of under this umbrella of serverless. So, whether or not you're ready to build cloud-native applications comes down to a whole bunch of stuff, right? You're going to need to be okay buying into an abstraction. And with that, dealing with all these fears that you might have around lock-in or being in a walled garden. You probably also want to have a bit of an appetite for adopting new tools and technology, especially if you're buying into the stuff coming out of the Cloud Native Computing Foundation, because the pace of change is not slowing up in this space. You will need to learn new skills, and you might need to hire new types of people, but you absolutely are going to have to invest in skills to make this stuff work. And you're probably going to also have to accept the constraints of whatever platform you target for your application. You've got to deal with that, and it's just going to come down to a trade-off. Now, for me, when you target somebody else's abstractions, especially when you start making use of a public cloud provider, you start buying into those higher order abstractions that they provide, you get the chance to reduce your operating costs. You can move a lot faster. And more likely, you're going to be able to handle scale and resiliency and security, especially significantly better than you can yourself. When AWS first launched their cloud providers stuff, they used to talk about this phrase, undifferentiated heavy lifting. They say, we created AWS for ourselves because we were tired of our teams doing undifferentiated heavy lifting. What they meant by that was work that is difficult that doesn't actually make you better than anybody else, doesn't differentiate you from the marketplace. Anyone can rack up a machine. Is our ability to rack up a machine going to make us the best place to sell books? No, that's a commodity. When it comes to that undifferentiated heavy lifting, why are you doing it? Why are you configuring virtual machines? How does that differentiate you from anybody else? You want to focus on being the best bank. You want to focus on being the best mobile phone company, the best retailer, the best charity, or whatever it is you might be. And a lot of the work that you do is just rubbish noise stuff that somebody else could do far more efficiently than you could. Pay them for that responsibility and focus what you want to do. Focus on your job of writing code for your customers. If you want to know more about all of this stuff, I've got a whole 3-hour tutorial on serverless and how that works in microservices, which you can find out about on my website. But if you want to know more about this and any other talks I do, most of the talks I've done are available to watch freely on YouTube and things, and you can find lots of links over on my website, including links over to sort of my training courses and things I offer as well. But anyway, thank you very much indeed for your time. So we've got a little bit of time for questions. If anyone has any? Go ahead.
You showed the cloud primitive, this open tracing in Jaeger.
Yeah.
Do you have any thoughts at all on open census?
So I haven't used open census much myself. I mean, I've just spent more, partly because of my background, I spent more time looking at some of the open tracing stuff. That seems to come up a lot more, so I don't really know that world as well. Certainly, I've been looking at some of the stuff that, I was always very hopeful that Microsoft would start supporting the open tracing API as part of App Insights and things like that, and they've not really adopted that. And I hold out hope in those areas, but yeah, I can't speak to open census specifically. Any other questions? Okay. Well, I'll be floating around for a little bit before heading to the airport, but I hope you enjoy the rest of the second inaugural NDC Copenhagen, and I hope you come back next year or one of the other events that we run around the world. But thank you very much indeed for your time.